Good morning, viewers. Welcome to MouShauk. Today, I'll be starting with the first element of the periodic table, that is hydrogen. Now, why this periodic table? In this periodic table, rather in the periodic table, why this element is considered to be the first one? Because it has what? It has one valency. Okay, it has only one valency. It has only one shell. One uh, electron in its valence shell. So one electron in its valence shell, it has one valency and it has only one shell. So it has been named as the first element in the periodic table. Okay. Now uh, further studying, we will come across the topics. Those are: how was it discovered? Where was it? Who discovered it? Okay, where is it? Where does it occur in the? How does it occur in the free state or the combined state? Then, what is its position in the periodic table? What are the tests? What are the uses? Then, what are its similarities in which? With which elements it is similar with? Okay, we will see that it is similar to the alkali metals as well as it is similar to the halogens also. Okay, now its properties, physical properties and chemical properties, its preparation, that is general methods of preparation, and also the manufacturing, the industrial processes of manufacturing. Okay, so we will come across all these. And the physical properties, we will come across the color, odor, taste, physiological nature, density, solubility, liquefaction, occlusion, all these. Then chemical properties, we will come across is reaction with the non-metals, reaction with metals, reaction with metal oxides, or its reducing properties. Then combustibility, then hydrogenation, action towards litmus, redox reactions. Okay. Now, in the preparation of hydrogen, we will come across how is it prepared in the general method, that is by the reaction of metals with water, by reaction of metals with dilute acids, by the reaction of metals like zinc, lead, aluminium with dilute acids and caustic alkalis. Then lab preparations of hydrogen using granulated zinc and diluted sulfuric acid. Then in the industrial processes, we will come across by electrolysis of acid-related water and Bosch processes. Okay. So first we come to the discovery of hydrogen. Okay. So it was first prepared by Robert Boyle in 1672. Robert Boyle prepared it first in 1672. But the credit of the discovery of hydrogen goes to Henry Cavendish, for this discovery in 1766. Okay, so he prepared this gas from iron and with dilute acids. He prepared it. Okay, he established its elementary nature. He showed that hydrogen, when burns in air, produces water, and that's why he named the gas generally the inflammable air, as it was combustible. Okay, as it is combustible gas, so he named it as inflammable air. Okay, but as hydrogen burns to produce water, Lavoisier in 1783 he named it hydrogen. Okay, as water is formed after its burning, so it was named as hydrogen by Lavoisier in 1783. Okay, which means hydrogen means water former. It's a Greek word and it's meant water former. Okay, that's why hydrogen has been named. And due to its combustible nature, Cavendish named it as inflammable air. Okay. Next, we come to occurrence. In the free state, it's found in traces in the Earth's crust and atmosphere. In the volcanic gases, it's found as 0.025%. In Earth's crust, it is found as 0.98%. In the Earth's atmosphere, it is found as 0.01%. It is also found in the sun's and the stars' atmosphere. In large amounts, it is found there. Okay. Then in the combined state, it is found as compounds of hydrogen with carbon, oxygen, and nitrogen, which the plants and animal tissues are made up of. In the plants and animal tissues, okay, they are found as they are found as compounds, okay, where hydrogen is combined with carbon, oxygen, and nitrogen. Okay. Now, it is the characteristic constituent of acids, alkalis, hydrocarbons, proteins, and even sugars, starch, petroleum products, carbohydrates, fats, okay, etc. Then it is also found in water as 11.1% by weight. Okay. Now, its position in the periodic table. Okay. So I told you it is considered as the first element in the periodic table. Its atomic number is 1, okay, because it has 1 electron in its valence shell. That's why its atomic number is 1, and therefore it belongs to the first period and the first group of the periodic table. Okay, but its properties are not similar to those of the other members of the first group. Not all the properties are similar to the first group element. Okay, that's why its position in the table has been a matter of controversy and debate since Mendeleev's presentation of the table. Okay. Since Mendeleev has given the periodic table, there's the controversy of placing this hydrogen in which group, in placing this hydrogen in the periodic table. Okay, because it does the properties of all its properties does not match the first group elements. Some of it matches with the first group elements and some of them matches with the halogens. Okay, the first group elements are alkalis, okay, alkali metals. Then because of its dual nature, some properties resemble the group 1A elements, that is the alkali metals, and some resembles the group 7A, that is the halogens. Now, therefore, Thomson suggested to put it at the top of the table. That will not disturb the symmetry of the modern periodic table. Okay, that's why it has been considered as the first element in the periodic table. Next, we come to the similarities between hydrogen and alkali metals. See, what are the similarities we find in the hydrogen and the alkali metals? Like electronic configuration. Electronic configuration, it has 1 electron in its outermost shell. Alkali metals also have 1 electron in the outermost orbit or shell. Okay. Then valence electron, 1 valence electron it has. Even the alkali metals also has 1 valence electron. Ion formation, valency is 1. Alkali metals, the valency is also 1. Ion formation, it forms cations, that is positive ions. Even the alkali metals also form the positive ions by losing 1 electron, both the cases. That's why they are known as electropositive ions. That is all you can say, electropositive characters they have. Okay. Then they are reducing power. This hydrogen as well as the alkali metals, they both act as a reducing agent. Like copper oxide reduced by hydrogen to form copper. Oxygen has been removed from the copper oxide and water is formed. Even the alkali metals also reduce copper oxide with copper and sodium, or rather alkali oxides are formed. Metal oxides are formed. Then burning, hydrogen burns in oxygen to form its oxide, that is water is been formed with a pop sound. Okay. Even hydrogen combines with oxygen to form hydrogen peroxide. Okay. But it burns with a pop sound. Now, alkali metals also burn vigorously when heated in oxygen to form their respective oxides. Okay, like lithium forms lithium monoxide, sodium forms sodium peroxide. Okay, Potassium, rubidium, cesium, also they form superoxides. Okay, with the general formula of MO2. Okay, MO2, that is superoxide. M stands for the metal. Okay. Lithium or monoxide, its formula is Li2O. Sodium peroxide, Na2O2. Then combination with the non-metals. They react, that is non-metals, hydrogen reacts with the non-metals like oxygen, sulfur, and chlorine to form their respective compounds. Like they form with oxygen, it will combine to form H2O, with sulfur forms H2S, and with chlorine, it forms HCl, okay, hydrogen chloride. Then reacts with the alkali metals, they react with the non-metals like oxygen, sulfur, and chlorine to form their respective compounds. Like sodium forms Na2O, sodium oxide. Then with sulfur, it forms sodium sulfide, and with chlorine, it forms sodium chloride. Okay, sodium. I'm telling about only sodium. Okay. Now, let's see the similarities between hydrogen and halogens. Like electronic configuration, hydrogen has one electron less to the nearest inert gas. Nearest inert gas is helium. Helium has two and hydrogen has one electron in its valence shell. So one short of the nearest inert gas. Even the halogens also, they have one electron less than the nearest inert gases. Like chlorine, it has 2 and 7. That is, it is short of one electron. That is helium, it's very close to neon. Sorry, not helium, it's very close to neon, which has 2 and 8 electrons on it in the shells. Okay, in its electronic configuration. Chlorine is also having a 1 electron short of the nearest inert gas, that is argon. Okay. Then valency hydrogen is 1 and halogen also has 1. They accept both of, that is hydrogen as well as halogen. Both of them accept what? 1 electron to attain the electronic configuration to the nearest inert gas. That is, it forms hydride, and these all forms their fluorides, okay, iodides. Then formation of ions, as it is 1 electron short of the nearest inert gas configuration, it has a tendency to form an anion. Okay. Even the halogens also, they are, as they are also short of 1 electron to the nearest inert gas configuration, they also have a tendency to form anion. By gaining 1 electron, they form an anion. Okay. They have an electronegative character because they accept 1 electron, and therefore hydrogen also has an electronegative character, and even the halogens also have an electronegative character. Okay. They are also non-metals. Hydrogen is also non-metal. Halogen is also a non-metal. Then physical state, hydrogen is a gas. Even halogen are also gases. Okay. Atomicity, it exists in the form of diatomic molecule. Hydrogen, they exist in the diatomic molecule. Even the halogens, they also exist in the as the diatomic molecule. Like F2, Cl2, Br2, I2, these are all diatomic molecules. Okay. Now, let us see some differences between hydrogen and alkali metals and hydrogen and halogens. So, difference between hydrogen and alkali metals is that hydrogen has only 1 shell. Alkali metals have 2 or more shells. Hydrogen oxides are neutral oxides. Sorry, hydrogen oxides are neutral oxides, that is H2O, whereas alkali oxides, they are basic in nature. Na2O, K2O, etc. They are all basic in nature. That is, they form a base. Now, hydrogen and halogen. Hydrogen, again, it has only 1 shell. Halogen has 2 or more shells. Then hydrogen oxides are neutral oxides, whereas halogen oxides are acidic oxides. Cl2O, Cl2O7, etc. These are all acidic oxides. Okay. Now we come to preparation of hydrogen. So first we come to the general methods of preparation, that is reaction of metals with cold water. Okay. First, we will see potassium with cold water. Okay. When we put potassium in the cold water in a beaker, we will see that as the potassium density is 0.86 grams per cubic centimeter, it floats on water. It is slightly less than water. The water has 1 gram per centimeter cube, and it has potassium has 0.86, so it will float on water. It melts at 62 degrees centigrade, forming a silver gray globule which darts about on the surface of the water. Okay, it will melt at 62 degrees centigrade, forming a silver gray globule. It's a ball-like structure which will dance about on the surface of the water. Okay. This reaction is highly vigorous and highly exothermic reaction. Okay, liberates a lot amount of heat. Okay, so the formula, the reaction will be 2K plus 2H2O forms 2KOH and H2. This reaction is so exothermic that it will catch fire. It burns. Okay, the potassium burns, forming a lilac-colored flame, and bubbles of hydrogen gas is seen, and the reaction, the product which is formed makes the solution, the water solution, colorless, soapy, and alkaline. Okay, due to the formation of an alkali, a base is formed with potassium, that is KOH, which is an alkali. As this potassium burns, it catches fire very easily, and this reaction is so exothermic, so vigorous that it will catch fire. Okay, as soon as it comes in contact with the cold water. So these metals are kept in kerosene, in a bottle which is covered with kerosene. Okay, otherwise it will come in contact with the moisture and it can catch fire. Okay, and another thing is that although pure hydrogen burns in the pale blue flame, okay, it will burn, pure hydrogen will burn with pale blue flame, but we can see the lilac colored flame when potassium is burned in hydrogen, in water, okay, cold water, due to this color comes due to the potassium burning, potassium vapor, this lilac color comes. Okay. Same thing happens with sodium. Sodium also is slightly little dense than water, 0.97 grams per centimeter cube. So it will also float on water, and it will also form a silvery globule darting about on the surface of the water. It will melt at 97 degrees centigrade. It is also a highly exothermic reaction and vigorous reaction, but it is slightly less than potassium. Okay, and the product is formed is sodium hydroxide and hydrogen gas is liberated. It will also catch fire and burn with a golden yellow flame, like potassium when it burned in cold water, that was lilac flame. Here, sodium will burn with a golden yellow flame. Okay, and bubbles of hydrogen gas will be liberated, and the solution will form a colorless solution with a soapy, slightly warm and alkaline solution will become like that due to the formation of sodium hydroxide. Okay, that's why as it catches fires very soon, again this sodium is also kept in kerosene. Okay, so that this kerosene cuts off the connection between the metal and the atmosphere, because atmosphere contains water vapor. Okay, that's why as it is so exothermic and so vigorous, this reaction becomes. That's why sodium amalgam and potassium amalgam are used. That is an alloy of sodium with mercury or potassium with mercury. Okay, which reacts smoothly with water. And from these amalgams, hydrogen can safely be prepared. Okay. Next, we come to calcium with cold water. Calcium, it will also liberate with cold water, hydrogen with cold water, but here, when it is kept inside the water, it will sink inside the water because it is more denser than water. So it will sink at the bottom of the container. Okay, this reaction is less vigorous than sodium, and In this case, calcium hydroxide is formed and we can see bubbles of hydrogen gas and the solution will turn milky, turbid and alkaline. And if we put some red litmus solution, it will turn lead litmus into the solution, it will turn blue. In all the cases, sodium, potassium and calcium, the red litmus will turn blue. Okay, because this will prove that the base has been formed after this reaction. And this alkaline nature can be proved from this red litmus test. Okay. Now, reaction of metals on hot wood, like magnesium. Okay, magnesium comes in the reactivity series. First comes the what? First comes potassium, then sodium, then calcium, then magnesium. So magnesium does not react with cold water, but with hot water, or rather boiling water or steam. It will react with to form hydrogen, to liberate hydrogen. Okay? The magnesium slowly reacts with boiling water, forming what? Forming magnesium hydroxide, that's also a base, and hydrogen gas is liberated. So the reaction stands like this. Magnesium plus 2H2O forms magnesium hydroxide plus hydrogen is liberated. Now with steam, this reaction becomes first. If we keep magnesium ribbons, so this is the apparatus which we use during magnesium to liberate hydrogen. Sorry. So magnesium ribbon is kept in this place, in this tube, and the boiling water is kept, the water is boiled here, the steam is liberated, which moves into this place where magnesium ribbon is being kept. This will make the magnesium ribbon crumble down and it will catch, it will turn into white ash, it will burn with intense white light and it will turn into white ash. Magnesium oxide will be formed with further heating. When it is heated from down, that will crumble down, okay, and it will liberate hydrogen gas when it is exposed to more steam. More steam when it is exposed to, it will liberate hydrogen gas. This is collected over water. In the beehive cell, it is kept. This is the beehive shell where it is kept, and this gas will come and collect over water. Okay. So this much for today. We will discuss some more preparations and the rest of the chapter in my next video. Till then, go through this. If you have any doubt, please write in the comment box. Okay. Do meditate before you start your day. Do subscribe if you have not subscribed yet. Okay. And if you're liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And do meditate before you start your day. Okay, I have not done the meditation, but to continue with that. For today, I have not yet done it. But do make it a regular practice to meditate before you start your studies or any work you do. Start your day. Okay, and think that God is blessing you. Make a chart of what you have to do to the day you are starting with. Okay, and after the day gets over, you check that whether you have completed your task or not, how much have you completed, how much is left, and prepare for the next day preparation. Okay, so like this, you can check your progress and your day-to-day routine life. You can do it like this, making a chart, flow chart, and also you can make diagrams like this, and you can study like that also. Okay, so if you have any doubt, you can also comment me, or you can write at my email ID, that is kasturi74@gmail.com. Okay, so for the next video, please wait, and till then, goodbye and thank you.